Right. We are live. Everybody, let's quickly go through this. When I write the date, it means you are writing and you start writing the notes. Remember, just like at school where your teacher wants to see your notes, I want to see these notes. You thank me later, okay? Oh, Mr. Clarify, you are so boring, sir. Don't worry, you thank me later. Let's go. We are doing chapter 10. We have 12 chapters for Chem. Chapter 10 is the chemistry of the environment. I'm not going to do any boring topic for the next few months. We are going to do the big ones and we're going to get them out of the way real quick. Chemistry of the environment, you have to know three things: water, air, fertilizers. Okay? When you do air and climate. Then you do fertilizers. You have to know certain things about this. They can ask you. You don't disrespect anything in sciences, okay? It can come and it can cost you marks, so nothing gets disrespected. You do everything equally. You prepare. This is chapter 10. We are going through chapter 10 out of 12. We have 12 chapters. We talked about water, and what we started by talking about were the chemical tests for water. The two chemical tests for water. Let me make sure it's moving with me at the same time. We talked about how you can use cobalt chloride and how you can use copper sulfate here to test for water. Cobalt chloride, it goes pink when you add water. It will be blue before you add water. Copper sulfate will be white before you add water when it's anhydrous. When you add water, it becomes blue. These are special tests that help you know if the substance you're dealing with is water. As a chemist, you have to do thorough things. You don't do guesswork. It will cost you seriously. Because how do you know if it's an acid? And if it's an acid, it will react completely differently with water. You can cause some serious problems and an explosion. So you have to know what substance you're dealing with. And how do you test for water? There are two tests: cobalt chloride. Let me drink water. Excuse me. Cobalt chloride and copper sulfate. Then we went on to talk about the purity of water because we are going to work more on this, okay? What are the harmful substances that are found in water? We are about to work more on this. And the beneficial substances that are found in water. So first, before we talked about it, we talked about the purity of water. And we said when something is pure, as a scientist, how you know that it is pure, you check its boiling point and its melting point. We know the boiling point of pure water. We know the boiling point, the melting point of pure water. So if you want to know, is this water pure or does it have impurities, which means other things that are not water inside it, dissolved in it, whatever. So how do we check? We check its melting point. If it does not melt at 0 degrees, what happens to melting point when you add impurities? It drops. Things that are not pure, they melt below their real melting point. The melting point drops and the boiling point rises. So if you see water that melts before 0 degrees, or water that boils after 100 degrees. At 100 degrees, it hasn't yet boiled. If you see it passing that, then that's impure water. So anything, whether it's water or something else, pure substances have fixed, known melting points and boiling points. If these change, then you know that, I have impurities. And let me tell you, pure water is not dangerous. It does not conduct electricity. But once water has an impurity, it can conduct. If you put electricity into that water and you put your finger, you will go immediately. It will conduct once it has dissolved salts in it. So we have to check, is this pure water? All right, we'll see more of it. So just know about impurities, and purity of water. So on water, the boiling point will increase, the melting point will decrease. That's what happens to everything. It's not just water. All right? So the melting point will decrease and the boiling point will increase if the water is impure. You've seen that? Can we move on? Hello? Let's move on to talk about quite a few other things. Let's go. We start with a little bit of an easy thing, which is distilled water. We talk about this. Should I buy distilled water? What is distilled water when I'm looking for water to drink or something? What is distilled water? You can be asked. Okay. And why chemists use it? Right. Tap water. Tap water contains tap water contains dissolved ions, dissolved salts, and other impurities. And other impurities. These can all affect experimental results. These can all affect experimental results. Therefore, scientists have to use distilled water. Scientists do not use tap water in experiments because it has impurities. And because it has impurities, everything about it is false. Its melting point is false. Its boiling point is false. It will affect your results. So, distilled water is what is used in labs. How is distilled water made? How distilled water is made. What is distilled water and how is it made? How to make distilled water. How distilled water is made. Step 1. How do we make this distilled water, which we love, which has no impurities? Heat the water until it becomes vapor. Vapor is gas. You heat the water until it becomes vapor. Then step 2. Cool the water vapor so that it condenses and forms liquid water. And collect it. Okay? You collect it somewhere else. Let me explain something to you, students. A very special, easy way of separating things is by using their boiling point. If I have water mixed with oil or whatever, I can separate these things by using the fact that these things boil at different temperatures. So the water is going to boil, turn into a gas, fly out before the oil has boiled. And I can go and collect it. Here's your heat source. Then you connect the tube. You go and collect it here. You can put cold water here next to the pipe on the other side here. You put cold water. So this is cold water. what does it do? It cools the water coming in and it can be collected here. It can be collected. So you had a solution. In here, it was the solution. When we say solution, we are saying it's tap water. Now, you boiled this, you heated it until the water became gas. What you know is that things have different boiling points. So yes, water is now gas and it's flying out, but the other impurities are not yet gas. They are remaining down here because the water is now gone. So they are remaining at the bottom whilst the water is flying out. That water which goes out as a gas, you cool it on this other side so that it now becomes drops, serious cool water, and you can now collect it. This is now your distilled water. So what is distillation? Water that is distilled has gone through distillation. What is distillation? It's a method of separation where you separate things by using the fact that they boil at different temperatures. So the moment you hear the word distillation, we are using the different boiling points to separate things. Something will become a gas and fly away and go away whilst the other one is remaining because it's not yet a gas. Then we quickly collect the first one and we go. So we have separated them. When you now hear something being called fractional distillation, it is when you are now separating two things where their boiling points are so close to each other, like water and alcohol. So they are a little bit harder to do this. So what you come and do is you put something, a net here or something, which is called a fractionating column. That is what makes it be called fractional distillation. To catch the alcohol which is trying to escape with water, it will be caught on the fractionating column. This you do when you are dealing with things that have very similar boiling points. But normal things, normal things, you just use distillation. So distilled water is water that was collected and they did this process. Step one, what do? You heat the water until it's a gas. Step two, what do? You cool the water so that it condenses and forms liquid water. Okay? And collect the liquid water. You have cooled it and you collect it. This is now your distilled water. Water that has gone through distillation. Simple fixture. Very simple fixture. Okay, we haven't talked about a lot of important things here. We have a lot of important things that you would need to talk about as well. Here, important point is that distillation removes most dissolved impurities. How do they remove? They remain behind. They don't fly away with the water because the water is now in gaseous form. So all the things that were dissolved in the water remain behind. So distillation, it removes most of the dissolved impurities that were in water. Are we together? Hello, students? Okay. Right. Now, here is something called, which a lot of people confuse, which as scientists you must know. Natural water. I did not say pure water. Pure water has no impurities. I didn't say that. This is natural water. People confuse this with pure water. No. This is water from rivers, lakes, or ground water. groundwater, e.g., and aquifer. Geography. Aquifer. Okay. If you want to know an aquifer, it is a rock that stores. A rock that stores groundwater. This is an aquifer. So natural water is not, okay? Natural water is not pure water. No, 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 no. Water from a river is not pure. Water from a lake is not pure. Groundwater is not always pure. It may be. Okay? But it can have some salts, but those salts may not be harmful. Right. Now, uses. Let me say. Let me write this. Natural water is not pure. It contains many dissolved substances. Distilled water has nothing in it. It's many times not even nice to drink. So, please, natural water contains many dissolved substances. In other words, many impurities. Those are what we call impurities. Things that are in water that are not water. So please, students, don't be like the students that think, river water is pure. No, 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 no. It is not. Are we together? Are we together? Good. Now, just write a few things, 2 more things, and you're done. Beneficial substances. Beneficial substances found in water. 2 more things. Okay, just this and then the harmful, then you're done. And the lesson is over. Beneficial substances found in water. Okay, I want you to write here. Some substances dissolved in water. Some substances dissolved in water are useful. Examples. You must know this. 1. Dissolved oxygen. Dissolved oxygen. Dissolved oxygen. Okay? Water has oxygen dissolved in it. Really? Yes. Why is it important? This oxygen is needed by fish and other aquatic things that stay in water and other aquatic organisms. Fish need this. Okay, they breathe through their gills by using the water in the oxygen in the water for respiration. So fish do respiration? Yes. Every living thing does respiration, whether it's an animal or a plant or whatever. And fish need dissolved oxygen for respiration. 2. The other beneficial substance that is found in water is metal ions. Okay? Metal ions. E.g., okay, e.g., Ca2+ ions. Magnesium ions, Mg2+ ions. Na+ ions. K plus ions. These can be found in water. Okay? And they are essential. Say, some metal ions are essential. Okay? Example is calcium ions, magnesium ions, etc. Okay? These are not toxic. They are not toxic. No, 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 no. They are not toxic. However, they are harmful substances that are found in water. Some ions, let's put them. Harmful, here what did we write? Useful, beneficial substances found in water. Then you now skip 2 lines and say harmful substances found in water. Harmful substances found in water. What did you say? Some substances that can be found in water for one reason or another, but they will be in water, cause damage to the ecosystem. Some substances that can be found in water cause damage to the ecosystem. Examples: one, harmful metals. Harmful metals. Okay. Examples of metals that are harmful. Metal ions that are harmful. One, lead. Two, mercury. Three, aluminium. Four, arsenic. All these are harmful metals that can be found in water. All these are harmful ions that can be found in water. Harmful metal ions. Two, plastics. These can harm aquatic organisms. Plastics can be found in water and they can harm aquatic organisms by one, entangling animals. Animals can move, they're entangled in here. Two, filling stomachs. And once they do that, they cause starvation. So you can say causing starvation. Are we together? Then you have to put another harmful thing. Sewage. Okay. Then you put one more. Sewage can be found in water, and you can say this contains harmful microbes. And these microbes can cause disease. Okay. Lastly, one other harmful thing found in water is nitrates and phosphates. Nitrates and phosphates. These come from fertilizers and detergents. Are we together? So excess nitrates, excess phosphates, these are harmful. Why? These are harmful because they promote excessive plant growth. They are harmful. They cause excessive growth of plants. Starts growing and growing and growing. Huh? What will happen now? You're going to have the water, the oxygen in the water being lost. Once that happens, then the aquatic life starts being damaged. And that is what we call eutrophication. So you have done the background of eutrophication. In eutrophication, nitrates, phosphates from fertilizers get into water. They start promoting plants to grow and grow and grow and grow and grow and grow. And take up the oxygen from the water. Now, aquatic life does not have enough oxygen. Because remember, one of the useful things found in water is oxygen. Dissolved oxygen. Fish need it. Other aquatic things need it. But now it's going because you put nitrates in water. Why did you put nitrates in water? You were putting nitrates in your plants so that they grow. You were putting fertilizer so that your plants grow. But now the fertilizer has been washed by rain and has gone all the way to the water, to the rivers. Now in these natural water bodies, we now have the plants that were on top of these rivers growing too much. Oh my days, excessive growth. Now they are fighting for oxygen that the fish needed. That's deoxygenation. Now the aquatic life does not have enough oxygen. And it will be damaged, and that's what we call eutrophication. That's eutrophication. So write the next lines and you'll be done of eutrophication to say nitrates are from fertilizers, detergents, whatever you are doing. Now they are in natural water bodies, causing excessive, unrealistic plant growth in that water body. This causes deoxygenation of water. What are you saying? Isn't plants want to respire? So they're taking up the oxygen, right? Yeah, exactly. Now, though, what about the fish? They no longer have it, exactly. So what happens? They die. Good. What is that called? Eutrophication. So this causes deoxygenation of water. And this eventually damages aquatic life. Okay? I want you to say it eventually damages aquatic life. Put this and say this process is called eutrophication. Mr. Eutrophication, you are absolutely bad news. Yes. From a simple thing to a bad problem. Yes. Potassium, is it harmful? No. Is it beneficial? Yes. Potassium ions, calcium ions, magnesium ions, sodium ions. These are all fine. But if you say nitrates and phosphates, we have a problem. Or if you say any other toxic metal like lead and mercury. Lead, mercury, you are not good. You are toxic metals. Or sewage, or plastics, or excess nitrates, or excess phosphates. These things are definitely harmful. These things are definitely harmful. They cause eutrophication, the last two. So now, in the next lesson, we finish it up by talking about water treatment and we go to air. We see how do we treat impurities. Because when water is not treated, it has both insoluble impurities like soil, sand, what, and soluble impurities, like these ions that we said we don't want, or pollutants in water. And we'll see the 3 stages of water treatment and we'll be done. Well done. You have to know everything here. You can't lose much to water. No, 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 no. Anyway, that's it. Scientists, everybody, thanks. Let me stop.